Welcome everyone to Math Time. I'm Mr. Julius Ineta, or you can call me Boss G, and I will be your teacher for today's lesson. Good day, everyone. Our lesson for today is all about writing linear equation ax plus by equals c into y is equal to mx plus b and vice versa. The equations that we had last time were all linear equations in two variables. Any equation of the form ax plus by equals c, where a, b, and c are real numbers and a and b cannot both be zero, is called a linear equation in two variables. Remember last time, in writing linear equations, there are four different forms that we can use for us to write a linear equation in two variables. The first one, you have their standard form, general form, slope-intercept form, and point-slope form. Remember that the graph of any linear equation in two variables is a straight line. An important characteristic of a straight line is its slope. The slope of a line can also be used to determine if the graph of a linear equation is increasing or decreasing. There are three ways to find the slope of a line. So we can find the slope of a line given 2 points, given a graph, or given the equation. So in the equation, we need to transform a given linear equation in slope-intercept form, which follows the form y is equal to mx plus b, where m is the slope and b is the y-intercept. In writing linear equation, we can write them in different forms. Okay, so we can write them as standard form, general form, slope-intercept form, and point-slope form. So we will be concentrating on standard form and slope-intercept form. When we say standard form, it is written in the form ax plus by is equal to c, where a, b, and c are real numbers and a and b cannot be both zero. Say for example, we have here x minus 3y is equal to 7. On slope-intercept form, it follows the form y is equal to mx plus b, where m is the slope and b is the y-intercept, where m and b are real numbers. Say for example, y is equal to 5x plus 8. Now, how are we going to write a standard form or a linear equation written in standard form into slope-intercept form, or a linear equation in two variable written in slope-intercept form into standard form? Okay, so let's try some examples. Okay, so let's have here the examples. Write the following equations in the form y is equal to mx plus b. So all the given equations are written in standard form. Now let us transform it into slope-intercept form following the form y is equal to mx plus b. So let's have number 1. 5x plus y is equal to 7. So for 5x plus y is equal to 7, transpose positive 5x to the other side of the equation. From positive, that becomes negative 5x. So we now have y is equal to negative 5x plus 7. So it is already transformed into slope-intercept form. Now let's identify what is the slope. So the slope here is negative 5, and the y-intercept is equal to positive 7. So let's have number 2. So 4x minus y is equal to 2. Transpose 4x to the other side of the equation. So from positive 4x transpose to the other side becomes negative 4x. So we now have negative y is equal to negative 4x plus 2. So we divide both sides of the equation by negative 1. So negative 1. Y is equal to, so cancel yung negative and negative. So we have y negative 4x over negative 1 plus 2 over negative 1. Y is equal to negative 4 divided by negative 1 is positive 4x. 2 divided by negative 1 is negative 2. So positive multiplied by negative 2 is negative 2. Now the slope is equal to 4 and y-intercept is equal to negative 2. Let's have number 3. 2x plus 3y is equal to 6. Transpose 2x to the other side of the equation, so it becomes negative 2x. 3y is equal to negative 2x plus 6. So to remove 3 here, we need to divide both sides of the equations by the numerical coefficient of y, which is 3. So cancel 3 and 3. Y is equal to negative 2x over 3 plus 6 over 3. Y now is equal to negative 2/3 x plus 6 over 3 is equal to 2. So the slope is equal to negative 2/3 and y-intercept is equal to positive 2. So let's try some more. So let's try other examples. For now, we will be writing the following equations in the form ax plus by is equal to c. As you can see, the given are all written in slope-intercept form, and we're going to transform it into standard form following ax plus by is equal to c. So we have here y is equal to x plus 2. So we transpose x to the other side of the equation. That is positive, then it becomes negative. So we now have negative x plus y is equal to 2. So to remove the negative there, since x is the first term, it's better for us to have a positive first term. So we need to multiply the whole equation by negative 1. So negative 1 multiplied by negative x is equal to positive x. Negative 1 multiplied by positive y is equal to negative y equals negative 1 multiplied by 2 is equal to negative 2. And we now have the equation written in the form ax plus by is equal to c. So let's have number 2. Y is equal to negative 3x plus 6. So we transpose negative 3x to the other side of the equation. From negative, that becomes positive 3x. So we now have 3x plus y is equal to positive 6. And you now have the equation written in standard form. So lastly, let's have number 3. So x plus 1 is equal to y. So we need to transpose positive 1 to the other side of the equation. From positive 1, it becomes negative 1. And transpose positive y to the other side of the equation. From positive y, it becomes negative y. And we now have x minus y is equal to negative 1. And you now have the equation written in the form ax plus by is equal to c. We obtain the graph of a linear equation in two variables by plotting the points and connecting them on the coordinate plane. So points are associated with ordered pairs. These points are what we call as the solution of the linear equation in two variables. Solution of a linear equation in two variables is an ordered pair that makes a true mathematical statement of the equation. Let's say, for example, is negative 1, negative 3 a solution for the equation 2x minus 3y equals 7? So we will find out. So let's try and determine if negative 1, negative 3 is a solution for the equation 2x minus 3y is equal to 7. So we have here negative 1 and negative 3. Remember, the first number in an ordered pair is what we call as the abscissa. And negative 3 here is the ordinate. Abscissa is also called as the x-coordinate, and the ordinate is also called as y-coordinate. So this one represents the value of x, this one represents the value of y. So therefore, negative 1 here is the abscissa, which represents the value of x. Negative 3 is the ordinate, which represents the value of y. So using the equation 2x minus 3y is equal to 7, we substitute the values of x and y. So what is the value of x? You have there negative 1. The value of y is equal to negative 3. Is it equal to positive 7? So 2 multiplied by negative 1 minus 3 multiplied by negative 3. Is it equal to 7? So 2 multiplied by negative 1 is negative 2. Negative 3 multiplied by negative 3 is positive 9. Is it equal to positive 7? So negative 2 plus 9 is equal to 7, which is equal to 7. As you can see, the right side of the equation is equal to the left side of the equation. Therefore, negative 1, negative 3 is a solution. Solution to the equation 2x minus 3y is equal to 7. Now let's have here number 2. Find the solution for the equation 2x minus 3y is equal to 7, given that the value of x is equal to 2, the value of y is equal to 3. Okay, let me erase this one. So using the same equation, 2x minus 3y, given the value of x, what would be the value of y? So we need to find the value of y in order for us to find the solution for the equation 2x minus 3y equals 7, wherein x is equal to 2. So we have here a. So 2x minus 3y is equal to 7. X is equal to 2. So we substitute the value of x to the given equation. 2 multiplied by 2 minus 3y is equal to 7. So 2 times 2 is 4 minus 3y is equal to 7. So we transpose positive 4 to the other side of the equation. We have negative 3y is equal to 7 minus 4. So negative 3y is equal to 7 minus 4. It's positive 3. So negative 3y is equal to positive 3. You divide both sides of the equation by the coefficient of y. So negative 3 is cancelled to negative 3. Y now is equal to 3 over negative 3. So we have here negative 1. Therefore, if x is equal to 2, y is equal to negative 1. And what is the solution now? So the solution would be equal to 2, negative 1. How about if y is equal to positive 3? So let me erase this one so we can solve for it. So using the same equation, 2x minus 3y is equal to 7. What would be the value of x if y is equal to 3? So we need to find the value of x first for us to find the solution wherein y is equal to positive 3. So letter B. 2x minus 3y is equal to 7. The value of y is equal to positive 3. So substitute the value of y to the equation. 2x minus 3 multiplied by 3 is equal to 7. So 2x negative 3 times 3 is negative 9 equals 7. So we transpose negative 9 to the other side of the equation. We have 2x is equal to 7 plus 9. So 2x is equal to 7 plus 9. That is 16. Then we divide both sides of the equation by the coefficient of x. So 2. X now is equal to 16 over 2. That is 8. So the value of x when y is equal to 3 is equal to 8. Therefore, our solution would be 8 positive 3. Okay, can you follow? Very good. Okay, let's have one more example. Let's say, given the equation 2x plus y is equal to negative 4. Let us determine if 1, negative 6 is a solution to the linear equation. So remember, the first number here is the value of x, negative 6 here, or the second number is the value of y. So 2 multiplied by 1 plus negative 6 is equal to negative 4. 2 times 1 is 2, then positive multiplied by negative 6 is negative 6 equals negative 4. So 2 minus 6 is negative 4 equals negative 4. If you notice, the left side of the equation is equal to the right side of the equation. Therefore, 1, negative 6 is a solution. Okay, don't forget, it is a solution to the equation 2x plus y is equal to negative 4. Always remember, a linear equation in two variables has infinitely many solutions. Thank you for watching. I hope you learned something from me today. Have fun learning. Goodbye. See you on